Wayne. Thank you for that introduction. I'd also like to thank Pat and the entire staff for inviting both Lockheed Martin and myself to talk today. Pat, thank you. I saw you stand up and cheer there. I really do appreciate the opportunity to talk today a little bit about the Orion program and a little bit more about, I just want to share what a vision is that Lockheed Martin has come up with, together with some of our NASA folks on what could a mission to Mars look like. You're going to see an embedded video here in a little bit, and I'm going to talk about that. But even before I get started with the charts, there's kind of three takeaways. I think church, the pastors actually invented the three takeaways versus the lawyers, but we can argue that out in the hall. Three things I hope you get out of my talk. Number one is now is the time. I believe for the first time in history, or at least since the Apollo days, the time is now to go do deep space exploration. Everything is right. The society is right. The excitement is there. You've heard it in all the talks. Now is the time to go do this. So I hope you keep that in mind as we go through this. Also, it really is up to us, and this is a collective us. This is not NASA. This is not Lockheed Martin. This is everybody who is participating. This is citizens. This is academia. This is people throughout the world. Frankly, in my opinion, we are not going to get to Mars as a human society unless the entire world is involved in this endeavor. And so I hope you get that message as we go through here. But it's up to us. It's up to us here in this room. I loved the Hamilton song earlier. I think that was just very appropriate. This is the room where it happens. You folks, myself, everybody, this is the group that has to go do this. So let's keep that in mind as we go through. And then finally, I think most importantly is, this is a talk a little bit about return on investment. I wish I could go do calculations for what the return on investment is to Lockheed Martin investing or NASA investing in this. I don't believe that's possible. I don't believe it's measurable. I don't believe the ROI investing in going to deep space is a measurable thing. And I'm thinking as you go through this, I'd love to, hopefully some of you did see the Apollo 7 video that we just got done seeing, at least the first half of that. What is the return on investment of coming out of the dark side of the moon, reading the Bible, reading Genesis, and talking about that to mankind? That united the world. That is the kind of ROI that I believe we're going to be talking about here. So, okay, let's go ahead. I guess I got the clicker. See if we go. Okay, the first chart that I have is a little bit of a unique one. I'm actually not starting with anything relative directly to human spaceflight, but what I wanted to do is show the family portrait, as I call it, of what we have done, NASA, Lockheed Martin, all of the industry across the board with robotic exploration over the last 40 years. This may not be near and dear to some of your hearts, but it certainly is to mine. It's how I got started in the industry. I'm going to give a couple little stories here about some of the missions that you see here. And so you go left to right on the chart. We literally have done everything from the sun to Pluto and beyond. I think there was a special here on Voyager. Voyager launched in I think 1977, is now well beyond Pluto. New Horizons just flew past, took some unbelievable images here in the last 2 years. We have visited all of the planets. And what we have learned as an industry as a result is multifold. It's not just the science knowledge, which is tremendous. Obviously, we've discovered water on Mars. We've discovered water in places that nobody ever imagined. And of course, the theory is following the water, where we find water, we find life. And so that's been the scientific value. I think the other value that we're going to be applying to human spaceflight, and as we go beyond, is really getting the combination of human beings together with robotic probes in doing exploration, and also in how we manage these programs. Those of you who may have worked some of these programs, they're amazing. I always said you kind of start from the beginning, you write a proposal, 3 or 4 years later, you are flying. And because the planetary physics do not allow you to miss these launch windows. I've worked on several rover programs. I'm going to talk one here in specific, but that kind of program execution where you hit the target, you hit your budget, you execute, that is a huge necessity as we go forward and do exploration at cislunar space and beyond. All of us have to have that. We have to have that mentality. We have to be able to execute. We have to be able to use our resources wisely and those investments wisely. So not only is this an incredible mosaic of what the accomplishments have been over the years, a couple of specific examples. I actually worked, again, coming out of college, I was having lunch with a young gentleman here. I was going to be a basketball coach. So any of those who know me, I was not like a lot of you. You probably wanted to be astronauts and this, that, and the other when you were a kid. I just wanted to coach basketball. I played basketball in college. I happened to go to an engineering school, and the next thing you know, I'm working on robotic probes to Mars. One of the very first programs I worked on was the Mars 98 program, Mars Polar Lander and Mars Reconnaissance Orbiter. And for those of you who don't recall what that is, there were 2 missions that they were not successful. They both failed when we got to Mars. I spent 4 years working 70 hours a week, having children in the middle of it, on top of things, and having those missions not work. Having gone through that, what I want to leave the message is the sustainment was there. Even though these were not successful through the courage of a number of people, not just at Lockheed, certainly at NASA, those missions continued. We were able to learn from that. And a lot of folks don't know, I'd heard it, I think Steve mentioned it earlier, that we are still, the United States is still the only nation on Earth that has ever landed on Mars successfully. The Russians have tried it many times, but the Japanese, the Europeans, so on. Landing on Mars and getting into Mars orbit is an incredibly challenging problem. And what you see here on the screen behind me, this is success. This is what we want to sustain. We want to leverage this. And again, having the courage to go on and applying some of these things to the future missions, I think, is really important. So that being said, I'm going to start talking about a little bit more about space exploration and some of the specific missions. Now, you're going to see a number of the mission elements. I think folks are aware Orion has already flown the Pad Abort 1 mission. We flew the EFT-1 mission, Exploration Flight Test 1, back in December of 2014 successfully. You'll see more about EM-1 here in a minute. It's in full, not only in full production, it's in ATLO and powered testing right now down at the ONC. Ascent Abort test is scheduled in 2019, in April of 2019 right now. EM-2, which is near and dear to my heart, is in full production across the United States. You'll see some images of that coming up. And then as you see the manifest going forward, this is not just about SLS and Orion. You start to see propulsion module come in. You start to see habitat. You start to see logistics module, airlocks, other elements that are going to be required to build the Deep Space Gateway. And the participation that is required to do this, to get from the Deep Space Gateway to the moon, is going to require all players. So again, as some of these missions mature as we go forward, again, the goal being, let's get EM-1 flying, let's get EM-2 flying with crew, let's go start building the elements of the Deep Space Gateway. So again, this is sort of the manifest as you see today. Again, this is subject to change, but again, this is what we're working towards, and I'll show you a little bit of the hardware development on the Orion side that we're doing right now. So here's a kind of an animation of the EM-1 mission. EM-1 represents, it will be the furthest distance from Earth in the history of a manned capsule. It will go into a cislunar orbit. It's approximately a 21-day mission. It will be testing out not only the Orion capsule, the Space Launch System, the ground system development, all the infrastructure that's being done at Kennedy, the European Service Module. This is going to be a brand new flight, first time that we integrate with the ESM. Upper stage, it's going to be a very, very exciting mission, 21 days, testing out the avionics, testing out the heat shield, entry, descent, and landing, precision, GPS. It just goes on and on. This is the last proving mission, again, before we fly crew, which will be the EM-1 mission in late 2019. So you can kind of see the orbit and the retrograde orbit there. Okay. This animation, again, shows just a number of elements that are being done right now. You can see at the medium fidelity mock-up at Johnson Space Center, the crew testing out some of the displays and controls. This is at Ingersoll in Rockford, Illinois. EM-2 barrel is being machined today. This is the EM-2 spacecraft, not the EM-1. This is EM-1 down at the Cape. You can see it being moved into one of the clean room areas. It's fully integrated at this point, powered up, all the functional testing it's going through right now. Bremen, Germany, this is the European Service Module. You can see its integration and progress being made. This is at, let's see, this is the qual motor test that was done recently. The propulsion folks, a number of parachute drop tests. I think we're up to well over a dozen out at Yuma. Proving grounds, parachute system is coming along extremely well. We've done a number of tests, including failing chutes, et cetera. That testing is continuing, ongoing. You see the drop test of the crew module at Langley, again, to make sure that the seats are designed correctly. I like to call this the angry fire, or the angry trash can. Oscar the Grouch is very upset. That is actually the attitude control motor for the launch abort system. You saw a shot there at Plumbrook. Here you see a crew evaluation test going on. We actually vibrate the astronauts are looking at the crew displays. I went through that very quickly, but again, I want to just leave the message, this is all real, it's being done right now. EM-1 testing, crew evaluations, everything is going on across the country, and manufacturing for EM-2. Bill Gerstenmaier talked this chart at length. I'm not going to hit it anymore, but again, talking about the Deep Space Gateway, I kind of wanted to lead the audience from this chart that Bill talked earlier into the video that I'm going to be showing next on Mars Base Camp. So.
The time is now. At no other time in human history have we had the technology, the know-how, and the public excitement to get humans to Mars. We're building Orion today, right now, a spacecraft like no other designed for deep space exploration. But to get humans to Mars, we can't send Orion by itself. It needs to be part of a larger system that provides the supplies and the scientific equipment needed for a 3-year journey that will take us hundreds of millions of miles away. We call our concept Mars Base Camp.
Mars Base Camp is really straightforward. Let me break it down for you. It's an orbiting mission with 4 main sections and 2 of almost everything for backup. We have 4 large commercial solar arrays to generate electricity and power the spacecraft. For propulsion, we have 2 cryogenic propulsion stages and 2 tank farms to store the fuel, liquid oxygen and liquid hydrogen. Of course, the 6 astronauts will need room to live on their 1,000-day mission. So Mars Base Camp has 2 habitats and a living space to eat, sleep, and exercise. Most importantly, we have Orion. It's the command deck, with all the avionics for navigation and communications. Orion makes the whole spacecraft more reliable and gives the astronauts a safe ride home.
Because we've already started, we think we can launch this system in about a decade. Orion is already flight proven, and we are designing the Deep Space Gateway today. Soon, NASA and Lockheed Martin will launch an uncrewed Orion on the Space Launch System rocket for a mission called Exploration Mission 1, or EM1, to check out all the systems over 3 weeks in an orbit around them. After that, the next Orion flight, EM2, will be crewed. And on that launch, the SLS rocket will also carry the first elements of the Deep Space Gateway. The Deep Space Gateway is essentially a space dock where America and other spacefaring nations can perform revolutionary science and establish a lunar commercial economy. Through the 2020s, we will work with NASA to operate and assemble the Deep Space Gateway, and then build up Mars Base Camp and get it ready for flight. Finally, we will be ready to send humans to Mars aboard Mars Base Camp.
We've talked about how we can do it. Now let's talk about why. Mars Base Camp is about more than humanity's greatest adventure. It's about science, answering fundamental questions that scientists have been asking for hundreds of years. Where did we come from? Where are we going? And are we alone? From orbit, astronaut scientists have access to the entire planet's surface for rovers and drones to make real-time decisions about where to go and what to examine. We can retrieve a sample from the surface for study, and we can send the astronaut crew to the 2 nearby moons of Mars for an up-close look. And from orbit, we can confirm the site selection for the first human landing. At Lockheed Martin, we've been exploring Mars with NASA from the beginning, so we know what it takes to get here, how to operate here, and how to lead the world in doing it. Yes, Mars Base Camp is a concept, a vision, if you will, but whether it's this system that gets humans to Mars or something similar, the world is at a point in time where it has the means, the ability to write a new chapter in history, sending humans to the Red Planet.
I hope you got kind of the concept there. Again, the vision being, again, there's many ways to do this, and I'm not going to argue necessarily this architecture over others, but by leveraging sustaining programs, and I'll talk a little bit about the budgets here in a bit, leverage sustaining programs, continuing the funding, using technology that exists today, not going to unobtainium. This is a doable goal within our lifetime. I don't want to just have my kids be the first to get into orbit around Mars. I certainly want to be there, if not late in my career, certainly early in my retirement. So that was kind of the message of the Mars Base Camp. So from an investment standpoint, there's a chart here that you kind of see there's a line there up top that sort of represents investment dollars. You can argue whether that's government or a combination of industrial, commercial, et cetera, investment. But one of the major messages here, and you heard it earlier today, is for us to be able to free up the capital, the resources to go to Mars, to go build the infrastructure for cislunar, to go do landers, to go do these things. The things that are being done today, you heard a little bit more earlier today about ISS being commercialized, lowering the cost, the amount of resources that NASA has to spend to manage ISS into the future. You've heard from several of the providers for launches that are reusing vehicles. All this is driving the cost down. You look at what some of the efforts are being done on SLS and Orion to reduce the recurring cost of those vehicles as we get into production, more reuse on those vehicles. That's what represents that line that's going down that you see. What that is doing is freeing up capital to go do the really hard things, the habitat modules, the landers, the propulsion stages that are required to go to Mars. That is the future. So all of us, as I go back to that planetary exploration model, executing on the funds that we have in a crisp fashion, driving costs down, being innovative, doing more reuse, all of that is absolutely valuable. Because if you see here, the top line, I don't have that thing jumping up an order of magnitude. I'm hoping that dollar line will actually be going up in the future, but if we can have the mentality as a group, as an entity that we're very, very blessed in this country that we have the resources that we are getting, not just from the government, but our companies provide, finding better ways to do this, and this is exactly what this conference is about, driving those costs, makes that architecture possible. And I threw this mosaic in. Again, this is, if you look at it really carefully, it took me a minute when I first saw this, but again, if you go from the left, there's 9 mosaics here basically going all the way from Mercury out to Pluto. You could not have built this not too many years ago. You could not have built this photo. You think about it. Mercury, there's Venus. The Magellan spacecraft went and mapped Venus in the early 1990s. Obviously, the Mars images all the way to the right, New Horizon, Pluto. These images, we heard a lot about Cassini in the news here lately. The Cassini spacecraft that was at Saturn just did unbelievable science. That mission just ended a few weeks ago. Juno is in orbit around Jupiter right now, taking the most amazing images you've ever seen. We are exploring the solar system today. We are doing it in a very sophisticated way. We have got to take those approaches, those management approaches, those processes, apply it to human spacecraft. Mission success is ultimate, and you see the potential for what our exploration could be. And then finally, and if anybody finally tells me who this child is, they will win a prize. I've heard every time I bring it up, they say it's Paul's boss that's not happy with him. But what this message is we invest, investments leading to exploration, the economy. I don't think I need to preach to this group what that means. I like the ROI is immeasurable. What is the value of reading Genesis coming around behind the moon to society? It really is immeasurable. I guess I'll just kind of close with the 3 points that I brought up originally that, now really is the time for human exploration, deep space exploration of the heavens. The companies that are doing the innovative activities, you're hearing it at this conference, reducing launch costs, reusability, innovative technologies, that's the enabler for that chart that I showed to free up the investment dollars to go do deep space. So really now is the time to do it. And it really is up to us. It is up to this group to go do that. It is up to this group to make sure that this happens. It really is a team sport. We've heard that from many speakers so far today. We need to work this together. No one company, no one organization, no one nation is going to do this. And then finally, the ROI, embarking on a journey like this, it really is an immeasurable ROI. There have been studies done. I think there was a chart in one of the presenters earlier that I did a panel at University of Chicago a year or so ago where they measured the value of the LEO and GEO economy. It's in the hundreds of billions per year. It's just crazy. You know, and nobody imagined that when we first flew, you know, the first satellites into orbit. What is the value of the deep space economy between cislunar and Mars? I don't know that we can put a dollar figure on it, but just the inspiration. If you look at the time that we have right now in this nation, right? We're a divided nation between, you know, reds and blues. The world has issues, right? Nothing is more uniting than what we do. That's where the ROI, I think, is immeasurable. So thank you very much, and I think I finished just about on time. Okay, thank you.
But
I got a red light flashing, so I think I did it.
we have questions. We have questions.
okay.
So the first question that I think the group would like to ask you is, with so many launches in the future, are there any plans to partner with any companies that produce reusable rockets?
So I think when you see the larger architecture, there are elements of it that go all the way from LEO to cislunar to Mars. The answer is, by definition, I go back to my original statement, is this really is a game for everybody, right? This is not a, hey, we're only going to be flying SLS and Orions. This is, where can we fit elements of the entire industry into this architecture and this team? There's absolutely opportunity.
So the next question is, how does the investment in commercial development at LEO support or hold back progress in getting to Mars?
So, you know, I like to go back to the, you know, investment chart. As we invest in LEO and we reduce the costs of whether it's operating ISS, getting cargo launches to station, getting human launches to station, that is going to free up resources that enable deep space. So they do go hand in hand, and that's why this is such a partnership. If we can all agree, and I think this is one thing we want to do, I mean, gosh, if we can spend less government money going to LEO, enabling commercial companies to make profits, there is a win-win. It is a win for industry, it is a win for jobs, and it's certainly a win for exploration to be able to free up that capital and those resources. So it's not one or the other, it's both. It's
Good.
both that are very important.
Okay, last question that we have time for. Is the plan feasible if we assume flat or no growth NASA budgets?
So the plan that you saw, there was an intentional flat line. That flat line really has like a 2 or 3% inflation. You couldn't see the slope, but that's what it was assuming. That profile to get to Mars within the next decade or so assumes a flat NASA budget, also assuming we can significantly reduce the recurring cost of SLS, we can significantly reduce the recurring cost of Orion as we get into production. All of those entities, plus freeing up some of the resources, for example, for ISS. That's the assumption.
Very good.
Yeah.
Thank you very much,
Yep.
Paul. We appreciate
Thanks for
your
having me.
presentation
Thanks.
today.
You bet.
Right.